I'm Leah Jarrett, and I'm a developer advocate here at Google Cloud. Today, I'm going to be talking to you about how to build an interactive machine learning application using both Vertex AI and Looker's extension framework. I'll also be joined by my colleague Sarah, who's going to give a demo of using Vertex AI. So let's jump in. So before we actually talk about how to build a machine learning application, let's talk about why we might want to build one. Well, we really want to give business users access to the results of machine learning models. Oftentimes, business users need to go through data science teams or some sort of bottleneck to get access to the results of machine learning. And even if they do get access, they might have a hard time working with the results, analyzing it, and interpreting them to make real decisions off of it. So in this case, we really want to build an interactive machine learning application that empowers our business users to get access to the results of machine learning when and where they need it. We also want to ensure that the interface is usable for everyone of different technical levels, so that they can interact with it, create new predictions, and analyze the results without needing assistance. We also want to make sure that they have guidance on how to actually interpret the results of the machine learning algorithm, so they know what the results mean and how they can use it to influence real business decisions. So now let's talk about how to actually build this model. So to actually build a machine learning application, we can use different components of the Google Cloud data analytics and data science workflows. First off, we're going to use Vertex AI to actually create our machine learning models. So let's pretend that we're working for a digital marketing agency or a digital marketing team within an e-commerce department. We'll use Vertex AI to train two different machine learning models. First of all, we can use a classification model to predict whether or not a user is going to purchase an item if they see an advertisement. Second of all, we can use a time series forecasting model to predict the demand or the sales that we would get if we did not use any advertisements at all. This way we can measure the lift of our campaigns in the future. Now we'll actually train our Vertex models with data that's stored in BigQuery. And this allows us to take use of the scale and power that BigQuery offers so that we can prepare our data sets and import them to train our models in Vertex. But in order to actually run predictions from Vertex AI, predictions off of those models that we just created, we want to create a machine learning application that our business users can interact with. This is where Looker comes into play. So with Looker's extension framework, we can build a custom model that allows our users to run different predictions from Vertex and also analyze the results in a dashboard and Looker's Explore environment. So now that we know how all these pieces fit together, let's jump in and start talking about Vertex AI. So the first thing we need to do when creating our machine learning models is actually import those training data sets that we're going to use. We do this through fully managed data sets in Vertex AI. The really cool thing about working in the Google Cloud Platform is that all these tools are connected to each other. So we can have our retail and e-commerce data that's stored in BigQuery. We can transform and prepare it using normal SQL queries. And then we can import the results directly into Vertex AI. When we import the results, we're going to be looking at the type of data that we're using. In our case, this is all tabular data, and what we're actually trying to do with this data. So either time series forecasting or our classification model. The next thing we want to do is actually train our model. And in Vertex AI, you have a couple of different options. You can create a custom model using TensorFlow or your Python code, or you can use our pre-trained APIs if you don't have training data of your own. But what we're going to do today is use AutoML. And this is super cool because you just feed your data into Vertex AI and it will do some work behind the scenes to figure out what kind of machine learning model is going to be most appropriate for your classification or time series forecasting task. Once we have our model trained, we're able to use this model to make predictions. And in Vertex, there are two different kinds of predictions you can use. The first is online predictions, which you can get a single observation predictions in real time by deploying your model as an endpoint. But in our case, we're actually going to be using batch predictions. The cool thing about batch predictions is that you can use a table in BigQuery to trigger your batch predictions, and then also export the results directly to a new BigQuery dataset. This is key because in Looker, we connect directly to BigQuery. So if the results of our batch prediction are already exported to BigQuery, we can start analyzing them inside of Looker. So now let's see a demo of Vertex AI in action.
We'll train 2 models in Vertex AI using our retail data. First, we need to import our data from BigQuery into Vertex. There's a direct integration between Vertex AI and BigQuery. Here we'll create a dataset. This dataset will be used to train a tabular classification model. We want to import data from BigQuery, so we'll select here. And this is the BigQuery table we want to use to train our model. It's some data on orders, and we'll use it to predict whether or not a customer will make an order. We'll enter that BigQuery table here, and now we're ready to train a model on this data. We'll train our model using AutoML, which means that we don't need to worry about writing any of the model code. Our target column is made order. This will tell us whether or not the customer made a purchase. Here we'll select the columns we want to use for training. Here we'll want AutoML to maximize the accuracy on our model for the less common class. We're doing this because the percentage of customers who made an order in our dataset is much smaller than those who didn't. And with that, we're ready to start training. We'll follow the same process to train a forecasting model to predict sales for different item categories. Here we're using 7 days of data to predict what the category sales will be 7 days in the future. Now that we've trained 2 models, let's see how each one performed, starting with our classification model. Here we can see that 77% of the time, our model was able to correctly predict when a customer would make a purchase. We can also see feature importance. This shows us which features signaled our model's prediction the most. In this case, it looks like the advertisement category was the most important indicator of whether or not someone would make a purchase. With our trained model, we can now deploy it to an endpoint to get online predictions. We can also request batch predictions by creating a batch prediction job either in the UI or programmatically via the Vertex AI API. The result of our batch prediction job was written to a BigQuery table. For each row, we can see the percentage likelihood that a purchase was made. Here, it looks like there was a 71% chance that the customer made a purchase. Let's also take a look at how our forecasting model performed. Here we can see some evaluation metrics on our model. When we kicked off our training job, we specified that we'd like test predictions written to a BigQuery table. Let's take a look at that table now. Here we can see the sales predicted by our model compared to the actual sales on that date. Now let's see how to create a batch prediction job looking at one window of our time series data. When we're formatting our data for prediction, we'll pass it a BigQuery table with sales data for our 7-day context window, and then we'll provide the date we want to generate a prediction on. For this model, it's 7 days in the future. We'll leave the sales value for that row blank since that's what we want to predict. We can get predictions on as many 7-day time series windows as we'd like. Here we're just showing one for demo purposes. When this batch prediction job completes, we'll see the resulting predicted sales value for the date that we specified. In our Looker dashboard, we'll be able to visualize the predictions resulting from both of these models.
Great, thanks so much for that demo, Sarah. Now you understand how to create and train your models in Vertex AI. And at this point, we have 2 different models that we're working with. But now let's talk about how we can actually give business users access to interact with these models and analyze the results in Looker. First, let's start with an overview of Looker's architecture. Looker is going to sit directly on top of BigQuery, our data warehouse. And when you get started with Looker, one of the first things you do is create a data model using LookML, our semantic layer. Now, what's really cool about LookML is this is an abstraction of SQL. You're defining all of your different metrics, and Looker uses those definitions to create a query that's sent back to BigQuery when a business user is analyzing the results. So this makes Looker a great option for analyzing the results of our machine learning model. What's really cool is that we can define all the different metrics that are calculated on top of the results table in BigQuery, and this allows business users to interact with the results and explore, slice and dice, visualize, ask new questions of the results of the machine learning model. Now, from the analyst perspective, it's really valuable because we can actually parameterize the SQL table name for our model. This means that we can lay out the definitions once, But as we're making new predictions in Vertex AI, we can have the table name be pointed to the latest predictions. And this is all going to depend on what our business users use as parameters to send to the prediction request to Vertex. So now that we know that we're able to actually analyze the results of the machine learning model using Looker, let's talk about how we can give people access to a custom application to interact with Vertex AI. This is where we're going to use Looker's extension framework. Now, Looker's extension framework is kind of a new feature inside of Looker, and it's really cool because it allows you to create custom JavaScript applications that are hosted within the Looker development application. This means that you don't have to worry about hosting, authentication, authorization, and we even have templates to help you get started. In fact, we have a bunch of pre-built UI components so that you can easily develop a custom interface for your users to interact with. Using Looker's extension framework, we're going to create a custom UI so that our business users can enter parameters that will then be sent back as a batch prediction request to Vertex AI. Once Vertex AI processes our request, it'll put the prediction results directly in BigQuery so that we can analyze them in an embedded dashboard in our custom application. Now, if we were to build an application like this outside of Looker's extension framework, it would probably take a lot of time. We would have to create our front end, our back end, an auth service, and also connect back to Looker to embed that dashboard. But in our case, so much of this is taken care of by Looker and by the extension framework. So if we put all of this together, first we're going to use Looker's native technology to model our prediction results and create a data exploration environment for our business users to ask questions of the results. We can create a dashboard from this Explore environment and embed it in the custom application that we're going to create with Looker's extension framework. Next, in Looker's extension framework, we're going to create a custom UI that's purpose-built for our business users to interact with the machine learning models that we just created in Vertex AI. Now, what's really cool about this is we can use the templates and Looker JavaScript components to customize the UI, so it really is suitable for our business users' needs. And they have an easy time interacting with the machine learning models without needing to write any code or have any technical expertise. So let's go ahead and jump in and see this all in action inside of the Looker platform.
In Looker, I can navigate to my data science application from the left side panel under the Applications dropdown, or if you're using an earlier version of Looker, from the Browse dropdown. Now I can see my custom-built application for the marketing team to create targeted advertisement campaigns. On the left-hand side, marketers are able to control inputs to the model, like selecting users from a certain traffic source, country, gender, age, and previous purchase history. They can also specify what type of advertisement they're planning to run. For example, here we're predicting if we fed an advertisement campaign for accessories through a search channel. On the right-hand side, we have our dashboard to actually analyze the results of the model. So here we can see that when we ran the model, we fed in over 65,000 users that had an average age of 53, certain average prior spending habits, and we can also see their geographic location. Scrolling down, we can start to analyze the results of the batch predictions from Vertex AI. So here I can see that 2.6% of our user base was expected to make a purchase. We can also use that information to calculate our predicted campaign cost if we just targeted that 2.6%. And we can slice our likelihood to make a purchase, so that predicted measure coming from Vertex AI, by other fields in the user information, like how many orders they previously made, what their traffic source was, and what their age group was. Next, we can look at the results of our time series forecasting model. So to actually see what our predicted revenue, if we don't do anything, is for the next 7 days, and see that compared to prior historical sales. Now this dashboard is just like any old Looker dashboard. So as a marketer, I can explore from here, drill in. So I might want to explore and actually send these users who we predict to make a purchase off to an external application to, target them for that advertisement. Now that we understand how a marketer would interact with this application, let's start thinking about how we actually went and built this application. Like we said earlier, we built this using Looker's extension framework. So what we did was created some lightweight custom JavaScript to control the UI that we're seeing here. On the left-hand side, I actually used Looker components to create each one of these inputs. Let's see what one of these components might look like. For example, the checkbox group component is used for our first input. Now, I'm a data person and not a front-end developer, and although I did have to learn a bit of JavaScript and React to get everything working appropriately, most of the application was built leveraging these components and working off the extension framework code templates that are available. Now, if a marketer wants to change the inputs to the model, for example, only focusing on people in the US and maybe seeing what would happen if we ran an advertisement for jeans, I can click run, and I'm going to have to verify my identity to make sure I have permission to run the Vertex model. And then in the extension framework, my code is actually going to send this information to Vertex to create a batch prediction job. Now, before Looker actually talks to Vertex, it uses the Looker API to create a BigQuery table that contains one row for each person in that audience we created to predict on. And you can see we're going to have the gene search campaign, which is the fields that the user entered to actually see what would happen if we ran a certain type of advertisement. And on the details of the BigQuery table, we can see that it's set to expire tomorrow so that we aren't storing too much unnecessary information. And also it's named with this long hash, and this is basically a unique identifier for the prediction that we're running. Now, if we open up our extension code, we can see that after the BigQuery table has been created, it's time to make our Vertex prediction call. Here we're using Looker's extension SDK to create a post request to Google Cloud AI Platform. And in the input, we're going to specify things like our model ID, the location where this needs to run, and also our input data, so that BigQuery table we just created, and our output BigQuery data set. Since batch predictions sometimes take a few minutes to run, we send the user a message on Google Chat when the results are ready with a link to review. Here, we also include the same hash used earlier to bring the user back to the results of the model so that they can use the dashboard to investigate the results. The dashboard itself is just a regular old Looker dashboard that's embedded into our application using Looker's Embed SDK. So just like previous Looker API calls we made, this requires just a few lines of code and no authentication needed. We use the embed methods to pass in values for the filters based on what the user has entered on the left. You'll also notice that we have a parameter for our table name. This is the hash that was used to identify the prediction, and it's what's going to be used to make sure that we're leveraging the right table that stores the results of the latest prediction results from Vertex AI. Now, the great thing about this entire app is that it was simple to build, since Looker and Vertex do all the hard parts like model and front-end development, deployment, and authentication. And my marketers can interact with machine learning all on their own to get data when they need it.
Awesome. So now you've seen the entire process end to end. We talked about why it's important to create a purpose-built machine learning application for business users, and we gave a high-level overview of the architecture for building this application inside of the Google Cloud Platform. Then we showed you how to create 2 different types of AutoML models in Vertex AI, train them, and make batch predictions against them through the Vertex AI API. Then we jumped into Looker to talk about how we can analyze the prediction results inside of Looker's native application, and how that we can take it one step further with Looker's extension framework to build a custom application that's really purposely designed for your business users. So I hope this session inspired you to go off and create your own data science application. And to help you along the way, we've provided a couple of resources. First, some labs and training resources for getting started with Vertex, and then some resources for helping you get started with Looker's extension framework. Thanks again for tuning in, and I hope that you enjoy the rest of your time here at Join.